Just talk to my spokesperson. I like that. Well, you step back. Step back.
Yeah, sure.
All right, let's talk about it. So, section 13.3 is extra credit now. Chapter 14, I am going to talk about it a little bit on Monday and a little bit on Wednesday. But all I'm going to make you responsible for turning in is that. You got me? And that's actually from section 14.3. That's the most important thing for your immediate future if you're going into pre-calculus. That's the part that I can't let go of. Yes?
So then for our grade sheets too, it goes towards that too then? Because you said for all the homeworks you have to average a certain, for certain people you have to average.
Oh, yeah.
So that will include with that, just that now for chapter 14.
Yeah, because this is the other reason why I can't do a homework grade is because it's based on how much homework I assign, and I don't know how much until the end.
Right, yeah.
That's another reason why I can't really do a homework grade.
What's with online?
Yeah, so online, I'm going to post that online. Yeah.
Okay. I was going to say, if you wanted that, if we're only in not math line.
Yeah.
It'll be in math lab. Yeah, it'll be in my math lab. Just remind me if it doesn't get there.
So just that.
All right. Because how many guys are going to take statistics after this? I mean, how many guys are going to take 176 pre-calculus? 176, 170, 170. All right. Everybody that just raised their hands desperately needs to know the stuff contained in there.
First, the second.
The rest of it is sort of on the side. I teach some of it in Math 120, actually. But
Will chapter 14 be on the final?
totally. That idea will be on the final.
These are obviously long problems because it's not very big.
Nope, they're not very long problems at all.
Oh, really?
Nope. All right, let's do this.
Seriously? For real? Caught up on them?
All right, guys. So obviously this is a hyperbola
Nah.
or hyperbola, a non-combola. So it sits on the who axis, the y-axis. Right? Said that earlier. Vertices I'm going to find in a minute. Right. The center, though, is easy. I can tell the center is what? 0, 0, because there's no minus or something. It doesn't look like this. So I want you to realize all the work we're doing right now would work the exact same way if the center was different. I would just start counting from that new center. And I would do everything we're about to do. So it's not a big deal if it's been shifted. It's only a big deal if they didn't complete the square for you. So you have to complete the square. That will happen to you. How do I find how to find the foci? Yeah, what's 16 and what's this? 1. Okay. So C equals the square root of 17, which is roughly 4.1. Sounds good. All right, so let's see if we can graph what we know. And this is 4 squared, and this is 1 squared. That's amazing. So in the y direction, I'm going to go how far? 4. Yeah, good. So in the y direction, because that 16 is with the y squared, I'm going to go 4 in the y, 1 and the 4. And is that an actual point or no?
Yes.
Yes, because it's going to sit on which axis? The y-axis. That's an actual point. Make that really big ahead of time. 1, 2, 3, 4. So where are my vertices? I can answer this question now. My vertices are 0, 4, and 0, -4. See, so that question is a weird question. I don't answer it until I've actually started to make my graph. Because I figure out how far to go, but it depends on where the center is. And then I can go, oh, that's where my vertices are. I can see them. All right.
So you couldn't just square root 16 and know that's 4, -4?
No, it totally could. But the reason it was easy for this is because the center is 0, 0, so it's going to be those numbers. But what if the center was 1, 7?
Mm-hmm.
Then I would count 4 off from there, so I'd have different points based on that. So 4 tells you how to get to them. It depends on what the center is to really see what they are. So that's why I always say start to graph and then take a step and say, oh, now I know my vertices, I can see them.
But the center is 0, 0, you could just...
Center 0, 0 is easy, yeah. It's directly related to the 4 that we got. All right. And then how far in the X direction? That's crazy. So I put a little open circle there, a little open circle there, and now I can make my very skinny little rectangle. Yeah. Thankfully, this is the way this book does it. Some books do it differently, but I won't. They get a little more in depth about those equations of these asymptotes. I mean, so I can draw on these asymptotes through the corners. Through the corner. Jeff, can you do it? I don't know, Jeff. Through the corner. Should we cool with that? Yes, you could probably do it better than me, but you just draw from the center. Wherever the center is, it's easy here because it's the origin, and then go through the corner. Now, like we said from the beginning, it's going to sit on the y-axis. So it's sort of like that one, just reversed. So it's going to be up here. So it's going to be relatively skinny. Just like that. And the focus was 4.1. 1, 2, 3, 4.1. And that's why it's so skinny, because that's just so close to it.
Wait, zoom out real quick. What'd you do?
Zoom out.
On the focus?
Well, yeah, the focus here.
Yeah.
That's how I can find the foci.
Okay.
And then I go 4.1. So it's a little bit further than that, which makes sense because it has to be inside the curve.
Okay.
And then I go down 4.1, so that's inside the curve. Right there. 4.1 away from the center. I like it.
And the 4.1 on the y-axis
Because everything's happening on the y-axis for this one. Since the y squared was the positive part, it's the y-axis. The only thing I need, the x-axis in this case, is to help me make this rectangle.
Okay.
That's really the only thing it has to do with anything. I don't know if you pick up on this, but I'm trying to let us out really early today.
I'm picking up where you're going down.
Good. Almost. Well, I think we are basically done. Unless, I mean, does anybody have any... I mean, these are ones you just have to get in and try out about how they work, especially doing some ellipses and hyperbolas that don't have center 0, 0. But hopefully you guys understand. If the center here was 1, 3, I would have first went 1, 3, and then counted from there. And then I would have built my rectangle around it. All the work I just did would have been the same. I just would have counted starting at 1, 3. That's all that changes. That's it. It's almost too nice to believe.
So typically the 4.1 is kind of like the regular run.
No, the 4.1 is helping. I'm not sure how else to say that. Since the focus is so close here, that explains why the curvature is more extreme. Like over here, the curvature would not be extreme. I don't know how else to say. Like I consider extreme curvature to be one. Like if I'm going around a curve in a car, extreme is like holy shit. And if I'm going like, oh, this is nice. So when I say extreme curvature, that means like really fast turn, right? So the focus is 4.1. So if everything was happening on this one, it would be 1, 2, 3, 4.1. Is that really close to this vertex? Are they close? No. That's why it's such a nice, gentle curve. The more this gets pushed in, it's just like that cannonball, dude. I'm sorry. I forgot. I really love that image, though. You should look at Google cannonball to the gut. This dude, no.
The 70s.
Huh? What?
70s.
70s? Oh, the dude. Okay. All right. Okay. I think that's all I have. Yeah, so on the other side here is your practice test. This is related to chapter 14. Thank you for the dropping orders. And that's the first thing we'll talk about on Monday. I'll have the quizzes graded, obviously, all that kind of stuff. So this weekend is a really good time to catch up on homework.
What are tests? What day?
Test is Tuesday.
And then Wednesday will be.
Review for the final day. And then the final is Thursday.
Friday.
So on Monday I'll have the practice final too.
Oh, shit. Yeah.
Who's got hot dog or something?
Yeah.
Hungry. Salad. Okay, salad is almost a hot dog.